Hello students, today we learn about dihybrid cross. What is monohybrid cross? A cross between two homozygous parents by considering only one contrasting character. For example, tall plant cross with a dwarf plant. In a monohybrid cross, we get genotypic ratio that is 1:2, 2:1 and phenotypic ratio is 3:1 in a monohybrid cross. This cross With help of this cross, Mendel used two laws, that is law of dominance and law of segregation. And then he explained the dihybrid cross. In a dihybrid cross, Mendel considered a two contrasting character. He studied two contrasting characters at one time. So how can you define the dihybrid cross? So it is a cross between two river or homozygous parents by considering two pairs of contrasting characters. In this cross, we consider two contrasting characters or two pair of contrasting characters. We consider the shape of seed and color of seed. So these two contrasting characters shows like a round is dominant over the wrinkled seed and yellow color of seed is dominant over the green seed. So see this picture or this diagram. In this diagram, the parents are given. These are the round and yellow. These are the dominant, homozygous dominant. They cross with wrinkled green seeded pea plant. Wrinkled green, it is a recessive character or these character. These are the recessive characters. So you write the genotype. So it is a phenotype of a parent. Then genotype written as round for round, capital R for round, and yellow it is dominant, so denoted as a capital Y, capital Y. And for a green or wrinkled green seed, these are the recessive characters, small r, and small y, small. These are the genotypes of a parent. Then by meiosis, you know that the gametes are formed by the meiosis. So each gamete receives factors or the alleles. So it receives, so we get the two types of the gametes or the gametes, that is capital R, small y, and small r, small. These are the gametes. Then these gametes, they fuse together during fertilization to form F1 generation. After fertilization, embryo is formed and that develop to form young one. So that first generation is formed, that is capital R, small r, and capital Y, small y. So it is this character of F1 phenotype. We observe that is all individuals or all pea plants, they having rounded seed and yellow color, rounded yellow. So these dominant characters, they are appeared in a F1 generation. Then these F1 individuals or F1 hybrids, they get selfed or there is inbreeding between them to form the F2 generation. So we get gametes, different gametes of this F1 hybrid these gametes, how to make gametes? For that, see this is the you, you use the checkerboard. So you write the gametes, that is R, capital R and small r at one side, capital Y and small y at one end. Here, this capital R and capital Y they fuse together to form the first gamete, that is capital RY. Then second, capital R, small y. So this is small y, and this capital R is written here. So RY. Then small r, capital Y, and small r, small y. So there are four different types of gametes are formed. Then these four types of gametes they fuse together to form the 16 individuals. So the probability this individual is shown by using Punnett square checkerboard. So here is the checkerboard. So this checkerboard. In a checkerboard, we write the male gamete and female gametes at one end. Suppose this is the male gamete and these are the female gametes at one end. Okay. So capital R, capital Y, capital R, small r, small y, capital Y, capital small r, capital Y. So these are the different gametes we return in checkerboard, and by using checkerboard we find the F2 generation. So in F2 generation we get the ratio, genotypic ratio and phenotypic. Here in a F1 generation all individuals are found. These are the having rounded and elusive. All individuals they are the dominant. But in a F2 generation, the phenotypic ratio is 9s2, 3s2, 3s2, 1. This ratio is obtained by the Mendel. And he is surprised with that. Why this ratio is obtained? The recessive character that occur in a F2 generation, the 9 individuals, these are the having phenotype that is round yellow, rounded sheet with yellow color. So this if you draw the triangle, then these individuals, these are all these individuals are the rounded sheet with yellow color. So capital R, capital R, capital Y, capital Y. This first one is this plant having rounded sheet with yellow color. Then next capital Y, small y. Here y is dominating, therefore rounded yellow, round and yellow cells. Then here round and capital Y. So rounded and yellow color cells. Therefore, in a ratio that is a 9 individuals, these are with a rounded seed or the ratio of this rounded seed with yellow color that is a 9 and 3 individuals these are the rounded and green. So this capital R, small y, small y. Small y written denote the green color. So rounded individuals and y. Small y. So this is this one, it is round yellow, sorry, round green. This one is round green, and this individual is round green. So you draw a triangle in it. So this individuals, these are the rounded green individuals, and then remaining this one capital R, small r, capital, this is given first. In this triangle again, this one. So small r, capital Y, small r. So these are the wrinkled, this shape of the seed is wrinkled, and capital Y indicates the yellow color. So wrinkled yellow, and these three are the wrinkled yellow. And remaining one, these are the completely wrinkled green. So this ratio, phenotypic ratio is obtained, that is 9:2, K:2, K:1. So that is about the, so you find the genotypic ratio also. You make genotypic ratio by studying this Punnett square. Then in then just to erase it firstly. Then second point, that is we study the now different laws. Then now we learn about Mendel laws of inheritance. The first law given by the Mendel law of inheritance. The first one is the law of dominancy. Law of dominancy states that when two homozygous individuals with one or more contrasting characters are crossed, the alleles or the characters appear in F1 generation. These characters are dominant. Or the characters appear in F1 generation are called as a dominant character. Even so, see this example: homozygous tall and homozygous individual they cross to form the gamete capital T small t, and in a F1 generation we get capital T small t. So these hybrid talls are formed. So even in a this capital T small t, it is heterozygous condition. Even in a heterozygous condition, tall character, that is dominant, this dominant character is appear. So even in heterozygous condition, the dominant character is appear. So by this law state that the characters appear in F1 generation are the dominant character, and those are not appear, they are called as a recessive character. So this law is not universally applicable. Some exceptionals are there. This exceptional we study in the next session. In the next session, okay. In second law, that is the law of segregation. In second law, that is law of segregation. So first law of Mendel is law of dominancy. This state that the character appearing in F1 generation is a dominant character, or even in a heterozygous condition, dominant characters appear or it expressed. Then the lobe segregation state that see this cross, the tall homozygous tall and homozygous dark individual, they cross together to form the F1 hybrid. So these alleles, capital T and small t, these alleles, they are this capital T and small t, these two alleles, they come together in a hybrid, in a F1 hybrid. So this allele heterozygous condition is formed. So these alleles, they are together in a heterozygous condition in a F1 hybrid, but they do not mix. These alleles, the capital T would get separate and small t would get separate. So the alleles, they are not mixed with each other, they do not influence with each other, they do not affect on each other. These alleles, they get separate at the time of a gamete formation. Or each gamete, it contains only one allele, only one type of allele, either it is dominant or it is a recessive. Therefore, gametes are pure, and hence this law is also known as a law of purity of gametes. Okay, so this law states that when hybrid forms gametes, these alleles segregate from each other and they enter into the different gametes. Segregate means they get separate from each other and they enter into the different gametes. The gametes formed are pure and they carry only one allele. Therefore, it is either dominant or recessive. Therefore, this law is also known as a law of purity of gametes. So the question asked on this law as a explain or justify law or law of segregation is also known as a law of purity of gametes. Or other type of question like explain the law of segregation with suitable example or state the law of segregation. Okay. The next law, just wait first erase this. I think we understood this law of segregation. Segregation means only to separate gametes during formation of gametes, the genes or the alleles, they are separate from each other and they enter into the different gamete. Okay. Then the next, that is a Mendel law of independency. The third law, law of independent assortment. This law states that when hybrid F1 possessing two or more pair of contrasting factors or alleles forming gametes, this factor in each pair segregate independent of other. So these factors or the alleles they get segregate independent of the each other. Therefore, it is known as a law of independent assortment. And alleles randomly unite during fertilization. These alleles they randomly united in a fertilization. Therefore, we get ratio that is 9:2, 3:2, 3:1 in a dihybrid curves in a F2 generation. So this F dihybrid curves, it is useful to explain the lock independent assortment. Okay.